What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe and hit the bell notification icon, plus the join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's there's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show on Facebook and Twitter. And one last time, if you're new to the channel or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. Now, we are joined by 10th Man, Arwin, and a whole bunch of people in Discord. So welcome, one and all.
Good afternoon.
Hey, good morning.
Good morning, good morning.
Good afternoon.
Afternoon. Hello, one and all. Any signs of a physical geometric sphere edge, formerly known as Earth curve?
No, it's not real. It's fictitious. Can't be seen.
Well, I saw a television program on the Netherlands today, and it was actually, let me find it back. It actually said, what is it again? Earth from Space. That was the program.
Oh, right. Space. What's that?
Not a vacuum, but they'd like to think it is.
Oh, they claim it is. They definitely
It was
say
all
it's a
bragging
vacuum.
about, oh, look at all the incredible satellites, and we can do all this incredible video work and see here and there and zoom in and zoom out, let the time progress. Like, oh, in satellites, man, it's everything. It's the
They
future.
got to give you some good background sci-fi music, like.
No, it was really nice classical music, you know, just like they use on the nature documentaries and all that. So it was,
Nah,
but it
it's
was.
got to be Star Wars, man. Come on.
Nah.
Good
No,
morning.
but anyway,
guys.
their supposed space outlook on Earth, that was fisheye lens, just
Okay.
very clearly.
So what you're saying is you've seen a program that was called Earth from Space. Okay,
Yeah.
well, space, they say, is 10 to the minus 17 torr vacuum. Any evidence that you can have gas pressure, that's be the stuff that we're breathing, without the necessary antecedent of a container. And just before you answer, so for the audience's clarity, this black bit here on screen right now, that's claimed to be a vacuum. And this bit is gas pressure. And it's claimed that gas isn't filling the available volume in violation of natural law. So is there any evidence that you can violate this natural law?
Not really.
Not really.
No.
Not really
No,
any
no
evidence of an
evidence.
inviolable natural law being violated. Not really.
Yeah. Or really not. However you want to order those words.
Hey, Chocolate. I think Babs has got something to add. You want to add something, Babs?
Check. No, I was just checking my mic. I'm going to add something later on.
Fair enough. Any evidence of axial rotation?
Not of the Earth-based variety.
Any
Things
scientific
move, but
evidence of gravity? Hey, Chocolate, by the way.
scientific evidence of gravity,
Good morning.
no.
Good morning.
Good morning.
No, that's not possible. At least it doesn't seem to be possible to do that. Like gravity is a misconception, or rather a concept perceived to be real, yet it isn't.
Any evidence of the distance to the sun?
It's over there. Yeah, no distance. It moves with the observer.
any single viable hypothesis from any of the fields of astronomy, cosmology, or astrophysics?
Not viable ones.
I think that's pretty tough when you can't get past the first step of the scientific method. So, bit of a problem.
Yep.
Any evidence of the R value, Earth radius?
Black Swan.
At best, guys, we've disproven the radius.
At best.
At best. That's classic.
Might as well give that
Imagine
context.
All the textbooks they got to go change.
Mitchell from Australia, shout out to him. He was debating a chap called Mr. Sensible, and the Black Swan argument was put to him, and he understood and conceded all of the points in the modus tollens argument. And then he went on to say, well, given that all that is correct, at best all you've done is debunked Earth radius.
He's not the only one that said that.
Who else said that?
The guy that, what's his name? What's it gets it was debating, the vegan guy.
Cool.
The what guy?
He debated some vegan. I forgot his
Vegan
name.
Gains,
Vegan
that
something.
guy? Is that who you talk about,
he
Neil?
fell into the same trap.
Was it that Vegan Gains guy? Is that who you talking
That's
about,
him.
Neil?
What did
Yeah.
he say? What did he say?
He fell into
Basically,
the same trap. He goes,
pretty much the same shit. Like, so you. Go ahead, Neil. I'm sorry.
No, he was saying all you did was just prove that it could be bigger.
Wasn't he just vegan the question?
Yeah, unfortunately, that guy didn't even really understand his model. So I don't even think he could understand how detrimental proving the radius to be wrong was. So he just by far was not prepared to even have that debate. So,
But wasn't that what Mr. Sensible thought? That it was only like a 1 or 2 mile difference when he conceded that point, and come to find out, it's,
yeah,
it's
Now, he thought that we were laughing at him for him saying, "Oh, it could be much bigger," but he was only thinking about it's just a little bit bigger. He not realizing that still has a giant impact on the entire model.
Absolutely.
The funny part.
Is it worth me giving a rendition of the modus tollens argument at this stage? Carry on with housekeeping.
no, do it.
why not?
Did you say you'll do it?
No, I said go ahead and do it.
Oh, okay. If the Earth is a sphere with a radius of 3959 miles, then every distance to horizon measurement can be no more than 1.2 times the square root of the observer's height in feet. We have a demonstration of an image with the horizon beyond 10 miles, when it should be at approximately 1.2 miles, given that the observer's height is 1 foot. Now, if you calculate out how much bigger that would make a physical geometric sphere edge based on their mathematics, that would be 1.2 times the square root of the observer's height in feet, then the circumference of the Earth, based on that observation alone, would put Earth at the claimed orbital path of the Moon. That would be your equator. That's the circumference of the Earth if you use the Black Swan image to calculate it based on the presupposition that Earth has a physical geometric sphere edge. Now, obviously, this debunks the notion that we have a physical geometric sphere edge. It cannot be 10 times in excess of where it should be, because that would make it non-physical. So we are now told by our opponents that we do not see a physical geometric sphere edge horizon, in spite of the fact that the claim is supposed to be proven out by that very physical geometric sphere edge horizon blocking boats and buildings in the distance. So you can't have it both ways. You can't have the horizon both be physical, geometric and blocking things and never seen, incapable of being seen, never to be seen, doesn't exist. It can't be both. We only have one horizon. The horizon we observe in reality is not a geometric physical sphere edge. It needs to be, because they're going to be drawing tangents to a physical tangent point, otherwise known as Earth curve, the geometric horizon, to do geometry. This is the end of the globe religion based on its mathematics. You don't have a geometric sphere edge horizon, and you require one to do geometry.
Well, that's why I hate the Black Swan.
Check.
Yeah, we checked you earlier. You're all good.
Right. I think I got my mic audio issues fixed right now. Would it be a good time to pipe up right now?
You can pipe up whenever you like.
Right. So I had a question about a recent discussion that we've been having about perpendicular and what that actually means in geometry. So in the globe Earth paradigm, perpendicular means no, in the globe, sorry, I got that mixed up. In the globe Earth paradigm, level means perpendicular to the force of gravity. So what that means is that at any point on that ball, you're going to be pointed towards the center of mass. So level is always going to be perpendicular to the force of gravity. So if you're using a tool to measure that, like say a plumb bob is just like a pine cone that's being suspended on a string. So that tool is always going to point down regardless of where you are on the surface of Earth, because it's designed to work that way. So it's in the globe Earth paradigm, the plumb bob is being pulled down by gravity. That's why it's pointing down. But in our paradigm, it's more dense than the air surrounding it, so it's pointing down. So I'm just trying to understand what this argument surrounding this is. Like if you have a level at one location, then you have another level in a straight line in a different location. Well, why would you expect them to look different if they're all designed to work off of either density or gravity? They're all going to behave the same way, regardless of if we're on a sphere or a flat Earth.
Well, no. Based on what you declared they state as their paradigm, all plums are pointing in a different direction. That's their paradigm. So therefore, if their paradigm is true, that would be demonstratable. In other words, you wouldn't ever have parallel lines with plumb lines. That would never happen. Now, the facts are as follows. If you are a globe-believing geodesic surveyor and you go forth to measure the land, what you have just described will be imposed before any measurements are actually taken. That would be to say that you will draw a zenith with a presupposition that the plumb line you drop is pointing to a presupposed centre of an Earth that has already been determined by way of a datum to be a sphere. So if we're in England, we're going to drop a plumb line and assume we're at, I don't know, a 45-degree angle on that sphere before I do any measurements. So that will be establishing my point based on the datum with a presupposition that my plumb is pointing to the centre of a presupposed spherical Earth. From that point, that same surveyor...
Right,
hold on. From that point, where they presuppose a sphere is beneath them, they will then map out a tangent, because of the presupposition that they've made, plane. That is to say that from that moment forward, they will be using Euclidean principles which state quite clearly that parallel lines are never going to intersect. Completely the converse of the presupposition when dealing with plumb lines and drawing a zenith based on a datum. So from the point that they've presupposed a sphere Earth, they will then make measurements that assume plumbs run parallel. That would be Euclidean principles on the tangent plane that they draw out. So for the sake of argument, from the centre point of that tangent plane, they will assume that a quarter of a mile left of them, their plumb line runs parallel with the plumb line they dropped when they made their presupposition. That would be Euclidean principles holding true. Parallel lines for plums. Though they do not hold this axiom true because it does not demonstrate itself in reality. Now, while they might justify that by saying, oh, we only do that locally because there's only a very insignificant difference, a difference there must be and is not, and what they are measuring is done with Euclidean principles that demonstrate that principle as false, i.e. the principle that you declared by presupposition that plums move to the centre of a presupposed spherical Earth based on an assumption that you're dropping a plum based on a point on a datum that says you're on a sphere, and then using Euclidean principles that say that does not happen. You understand?
Right, I do understand. The assumption is that if we take a plumb bob and we place it at different latitudes, the plumb bob is still going to be pointing down, but the assumption is that at different latitudes, it's going to be at different angles, even though it's behaving the same way.
I see.
But
what's a latitude? And what's a latitude? Just
if you
one sec. Just one
line
sec.
up
Hold on.
like a
Hold on.
line
Hold
of
on. Hold on.
plumb
Hold on.
bobs in a straight
Hello.
line,
Hello. Hello. You've said this
you're
word.
not going to be able to tell.
Hello. Can you hear me? Latitude, you say? What's that?
Sorry, I can't hear you.
Latitude, you said? What is a latitude? I don't understand. What's that?
My thing's choppy.
What is latitude?
I think he's rejoining.
A latitude is a presupposed line on a globe.
So we're presupposing our position on a globe.
A latitude is a presupposed. I keep talking over you. Oh my God. A latitude is a presupposed line on a globe.
So after we take our presupposition that we're on a globe, we say we are here on a globe, and we're going to drop a plum that's at this particular angle to the centre of the globe that I'm presupposing we're standing on with the datum on its latitude line. From there, we're going to use Euclidean principles that declare Earth's flat. But prior to that, we're just going to make our presupposition known with a convoluted explanation about datums. But ultimately, it's just begging the question that they're on a sphere to only go forth and measure it as flat. Hope that's clear for the audience.
It's circumdicular geometry, Nathan.
It's a begging the question fallacy. They apply a datum. Or, in the case of Brian's logic when he was discussing it with actual geodetic surveyors, he will ask them if they're begging the question at that stage, as I've just detailed, and they will explain how they use a global positioning system, and they're not begging the question. Well, they are.
Well,
Global
yeah,
means
that
assuming
is
the
exactly what I said.
Go on, Babs. Go on.
That is exactly what I said before. I said that they're going to drop a plumb bob at presupposed latitude points, and the presupposition is that at those different points, it's going to be facing different angles. But that's all just presupposition.
Yes.
Now, Babs, can that be demonstrated?
How would you demonstrate?
That's my question to you. Can that be demonstrated, what they say, that if I go a distance away from one plumb bob, and I drop another plumb bob, that they're going to point, and the angle of the point, if you take it all the way out, would actually cross itself at a distance? Because
it's impossible because the distances are too large, so you wouldn't be able to tell if they're angled or...
You didn't hear my statement well. If I angle two plumb bobs inward, they will eventually cross, will they not?
That's the claim. That's correct. What they're stating as their presupposition cannot be bore out or demonstrated, and when they measure things, they work with the opposite principle being applied. Euclidean, i.e. they will never intersect.
How would you angle a...
Angling a plumb bob isn't an option because it defies what a plumb bob is. And Euclidean principles dictate that if you have two of them, they're running parallel with one another, and that is precisely the principles that will be applied after they beg the question that they don't do that. They're not measuring using those principles, they're measuring with Euclidean principles, but they're making the presupposition based on a datum, not based on what plumb bobs do, that each plumb bob they drop that will go directly down, vertical, that's not vertical. It's actually moving at an angle on their datum, even though they're looking at it moving down. Their presupposition is the only thing that defies it being vertical. Any more for any more, Babs?
Circumdicular.
Go on, Arwen.
Just saying that entire process you're describing, how they adapt perpendicular and all that to R, a center point on a sphere, I call that circumdicular geometry, which is basically a flat geometry wrapped around a ball, virtually. But it uses it.
You said R?
Flat. Yeah, R.
What R?
Well,
What R?
R-based geometry.
Oh. That would
Well, you gotta
require
have
an
R
R.
first. You gotta have R first.
Right.
Geometry, you can have all the R's you like, Won't make it real though, but they use it.
So pseudo R.
They use that way of thinking.
Pseudo R.
Circular
Is that what you're
geometry is
saying?
like a step in between that they engage with to imagine the Earth being a ball, while
Well, then you
using
can't-
the flat Earth effectively in their architecture and all that.
What about a perpendicular?
Well, that only really works with their tools in the real flat world, and in the circumdicular geometry. Yeah, perpendicular isn't really perpendicular. It's just R-based perpendicular.
Can you please give me a citation out of any dictionary for circumdicular right now, Arwen?
No, there's no circumdicular in the dictionary just yet, but I don't know if there ever will be. But if
Why
you
don't you
need
go to
any
Wiki?
citations, it's me.
Why
I
don't you
said
go to
it.
Wiki, Arwen, and put it in there so that you can really take him for a ride?
I don't know. I just hope it kind of catches on, because I think it is an eloquent description with more in there.
You're so
And-
poetic with pseudoscience.
Right. So yeah, I call it circumdicular geometry. It's just R-based geometry, and it warps everything. It doesn't really work in a technical sense when you do that, but it allows you to presuppose the Earth is a ball, despite all the readings of your tools that say it's flat. Like a
So it
plumb.
works in a just so story.
Yes, exactly.
Got it.
It's just there to reinforce their belief in the ball.
It's just there so that they
Any
are
ballers in
definitely concerned with it and worrying about it. That's the main thing, that they worry about being on a ball.
Worry about it?
Yeah.
What do you mean? They worry about. Well,
Being on
they
a
worry
ball.
that it.
I think they're more worried that they're not living on a ball from the way they act.
Yeah.
I think we covered it.
Although I
think
don't know how conscious they are of it. It might be very subconscious, visceral process. They're just defending their personal inner feelings, their youth dreams, and all that.
But why would that be when human nature knows nothing about living on a spinning ball? We all operate on a flat, stationary plane. I don't understand this
Because-
mentality of it has to be a ball when you don't even experience that. It's nonsense.
Because they grew up getting used to that and building their future dreams upon it. That's why.
Dreams of what?
Of their life, of whatever they're going to do, of however the world is going to change. It's all based foundationally on that the Earth was a globe, because that's how it was presented to them when they were blooming up in their dreams and like, what am I going to do with my life? And yeah,
It still doesn't explain premature sycamore pollination in north of England on a globe.
it doesn't. That's right. But I don't think anybody cares about that.
Well, I'm just adding to the story. If it's just a just so story, then they could be hanging on to it because they want to, in this just so story, have many planets and different life forms and become their own god or whatever. It's all a story.
All right. Well, if NASA told them that sycamorphic pollination actually was a thing because the Earth is a globe or whatever, then they'd have to take that.
Nathan told them that, not NASA. Nathan's got the
I know.
goods on that.
I know, but that's part of the example. Like, they're okay with whatever is asserted to them as long as that allows them to believe in the globe.
Well, you got to first prove there's a sycamore tree on some other planet first. You can't beg the question about sycamore trees that are in the north of England.
We're not having the same argument.
I think you are. It's farcical at both ends of the extreme.
Yeah, but I'm not actually talking about sycamorphic pollination. I'm talking about a ridiculous assertion that might potentially be added on. It doesn't have to be exactly that one, onto the globe cosmology, and then the globers would kind of be forced to officially accept it, even though they might not agree with it, because otherwise the foundations for their globe religion will weaken to them. See?
Unless there's a glober in here that can tell us all about their globe, prove it to us, so we can all pack it up and go home. That'd be nice.
There's nothing to prove. Don't have a geometric horizon. Fundamental to them doing geometry.
Don't take away all their hope. Maybe somebody will come in and say, yeah, we do have a geometric horizon.
The plumb bob, 2 plumb bobs prove the Earth is not a ball. Pretty simple.
I think there would have to be 3.
No, 2 would do it.
The more the merrier.
Well, 2 would do it, I think. I think he's right.
Right.
I mean, the more the merrier, but 2 is all you need. Because if you go to one end and I go to the other end and we just let the plumb bob do what the plumb bob does, they should point to the center of the Earth. And if we live on a ball, it's going to be on an angle, which means those lines would cross, which means there's no perpendicular, which means they're violating geometry, which means they don't have nothing. Bye-bye, globe.
Did we cover all the housekeeping questions?
I don't think so.
I think we did.
The distance to the sun was the last one I remember.
No, gas pressure.
Or hypothesis.
Oh, yeah. No, gas pressure without a container we covered after Earth curve, because you said that you'd seen a show that claimed to have shown pictures from space.
All right.
Right. I think the molten iron core hasn't been...
Yes, of course. The molten iron core. How could I possibly forget? Is there any evidence that we have a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
That's what the plumb bobs point to, right?
The molten iron core? Yeah, I guess so.
No, there's no evidence for that. Just to answer 10th man before my internet cuts off again, you can't angle plumb bobs. That's impossible.
That's what I was saying, sarcastically.
Worth reiterating, though.
Right. Yeah, we're on the same page, Babs.
Cool. That concludes housekeeping. Unless I missed in that little discussion between you two somebody in the Discord server offering up evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth. Did I miss anything? Anybody at all?
I don't know, but our side has plumb bobs and plumb babs, so we got them.
Cool. Well, as we've concluded the housekeeping, I'm going to do a quick shout out to, first and foremost, Brody Hyde, who's joined as a hyena. So thank you very much for joining as a channel member, Brody Hyde. Good to have you. Also, JQ, who I thanked in the pre-show, who was actually on the show, correcting me on my Jeopardy theme tune singing. So thank you very much for joining also as a penguin, JQ. And last but by no means least, shout out to Cleary, who drops a super chat and says, any evidence of a physical object rotating 1,000 miles an hour without vibration or centrifugal force? Question mark. Thank you very much for the super chat, Cleary. I really appreciate it.
Definitely no signs of whatever Cleary was just talking about.
Can we see who's in Discord? And if they're not talking, allow others to come in just to see if someone wants to bring up globe proofs, if there are any.
If you want to ask Righteous, he's maybe willing. We'll see what kind of mood he's in. If he wants to move people into the other room to get somebody who's a bit more talkative in.
He should be in the moderator mood.
I don't want to talk for him. He's sat next to you.
No, I know. I'm just egging him on there.
Well, we got the rumpus, son.
Oh, wonderful. Maybe he could answer the fictitious Earth radius again from that Association of American Geographers that he never did finish.
No, I
Last
wasn't
week.
allowed to. I was muted. Yeah, that's correct.
Muted again.
Yeah, well,
You're talking now.
yeah, I am. Yeah, amazingly, yes. Yeah, I'll go through it again. I mean, I think it was you who managed. You picked up how I explained it, and you actually repeated the exact definition of the difference between an effective radius and the real radius, between the apparent horizon and the geometric horizon. You did really well last time. So, just in case we don't know about this geometric horizon business, it doesn't look like a normal horizon, but it is a place that you can see, but it doesn't look like a horizon. So that's why I wasn't contradicting myself when I said you can't see the geometric horizon as a horizon.
It doesn't look like a horizon, Compass?
Sorry? Say again?
What he's asking you is, how can something that is let's say an elephant, not look like an elephant? And you're saying it is a horizon, but it does not look like a horizon. So what does it look like?
Because it'll just be where the geometric horizon is located by maths. But what we see is the apparent horizon.
So it is just where the geometric horizon is located with maths. So it's not a physical location at all.
It is a physical location.
Sorry, you just said it's a location that's identified by maths.
But it's a physical location.
Okay, so can you show me what it looks like if it's physical, please?
It looks like just a bit of water with which you can see beyond. It does nothing. It doesn't look special in any way. It's just a physical location.
So when you say you can see beyond it, my understanding of a horizon is that it demarcates where land or sea meets the sky. So beyond this horizon, there's the sky, right?
Yeah, well, that's your misunderstanding of what a horizon is, yes.
Explain to me what a horizon is. A real one.
There are about 4 horizons. There's the geometric, there's apparent, there is astronomical, and there is a topological one, which basically, so if you have trees and things, sometimes that's referred to as horizon. If you've got some mountains or something, there's another described as horizon. I think in the National Geographic thing that QE read out, I think they referred to that as the geographical horizon, not the geometric. So there are about 4 or 5 different definitions of horizon, but the one that we tend to like to think about, where the sky meets the water, obviously not a mountain because that sort of confuses the issue, but where the sky meets the water, that's the apparent horizon. That's what we would talk about horizon casually, but that's not the geometric horizon because, of course, refraction means it's moved away from where the geometric horizon. You can still see the location of the geometric horizon, so you can still see something that's the geometric horizon, but it doesn't look like a horizon. It just looks like a normal bit of water that you can see, and the apparent horizon is beyond it.
So it just looks like a normal... Hold on.
Go on.
Just looks like a normal bit of water. So you think a horizon is not a demarcation between, say, something that's in the near foreground. So if I put my hand in front of my face and I draw out a line with my hand, that could be a local horizon, let's call it that. It's not the geometric horizon that we should see if we're on a ball. It's a local horizon that I've created myself. There's also an astronomical horizon, which would be 90 degrees from your zenith, which would be a fictitious horizon that doesn't exist. So then we're left with the demarcation between land and sea, which by your standards on a globe is described as the geometric horizon, and it's described and defined as a visible location that demarcates land and sea based on your globe, Earth, religion.
No, that's the apparent horizon.
So we do not see a geometric horizon, and so it's definitely not visible. It's always just a piece of water that doesn't demarcate anything.
Correct. Yeah, you got it. Well done.
So it doesn't demarcate a point between land and sea.
Correct.
So if it doesn't demarcate the point between land and sea, is that always?
Well, if you for some peculiar reason you had non-standard refraction and you had an sort of inverted sort of semi-sinking refraction, then you would actually have the geometric and the apparent horizon saying, or if you went up very high and you were looking down, they would come close to one. They still wouldn't be the same, but they would get closer to one another. But because we have an atmosphere, because we have refraction, they very rarely coincide. They can get close.
What would coincide? Sorry, I'm a bit confused. What would coincide? What exactly is going to coincide with what? Because you're saying that the geometric horizon isn't visible, can't be seen, it just looks like water. It's not demarcating anything between anything and anything. I just want to clarify that first of all. It's not visible, it's not demarcating anything. The geometric horizon's only derived from maths, correct?
Correct.
So if it's only derived from maths and it can't be seen, it is not visible, how is it going to block a boat?
It doesn't. The effective horizon does that as a result of refraction, because you can see further due to refraction.
So the geometric sphere edge horizon does not block boats and buildings in the distance?
The geometry of the Earth blocks things in the distance.
Well, that would be a geometric horizon, a physical sphere edge. That would be the tangent point getting in the way then. So now you're saying we do see the geometric horizon blocking boats and buildings, even though it's never visible, can't be seen. I'm summarising how you die, and you seem to be talking through me. What's going on? We were really civil until my demolition of your double speak that you've contradicted yourself with, and now you're interrupting me again. It seems Rumpus can't debate. I'm now going to try. This is a third attempt. We'll count him off. Fourth attempt. He's getting further away from me summarising his contradiction. I clarified with you 3 separate occasions that we cannot see.
You misunderstood me.
That's the 5th interruption. I'm going to summarise your contradiction, but because Rumpus needs a little bunker where he can talk over everybody that summarises anything that he's contradicted himself with, he will interrupt continually, because that's what he needs when he's losing. So I'm just going to point out that he's losing and preventing me from summarising how he's contradicted himself by continually interrupting me. It's now 6 times. 7 times he's interrupted me. 7 times. So, if it's never visible, cannot be seen, is not optical, only exists in maths, it cannot block boats and buildings because it can't be seen and is not demarcating land and sea. So the geometry, as you phrased it, of the Earth can't be blocking anything in the distance. That's the 8th time it's interrupted me. I'll try and summarise it. Do you need a neutral platform? It's the 8th attempt of me summarising your contradiction. Do you need a neutral platform? Need a neutral platform, do you, to obfuscate this? Neutral platform needed, maybe. Maybe tell me that you've only got 3 words. Go on.
When is it my turn?
When I finished. When I finished summarising your death by pointing out that you've really given clarity to us not seeing something that does not demarcate land and sea and only exists in mathematics. Now, given that we can't see it, it doesn't exist, it doesn't demarcate anything and only exists in maths, it therefore cannot block boats and buildings. Now, when I point that out, you say, well, it's the geometry that's blocking boats and buildings. Yeah, that would be a geometric horizon then. So it can't be both. That's a contradiction, Rumpus.
Because the geometric horizon, because of refraction, is not the thing that's blocking you. It's the effective horizon. So, which is
but you said it only exists in math, Rumpus.
Yeah, it only exists in maths. You told us that. You told us that the geometry of Earth is getting in the way, but we can't see a geometric horizon. It makes no sense.
I'm in mid-sentence. If you let me finish the sentence, it'll all become clear. The geometry of the Earth is refracted. So that becomes the effective horizon. That's not the same as the geometric horizon. The geometry of the Earth and the geometric horizon are not the same thing.
I see. Okay. Thank you. 5
more seconds. Please, my 5 more.
No, so I'm not going to get a chance to respond. It's just going to be 10 minutes of you saying 5 more seconds, is it? You've made your point clear. You've said the horizon is refracted. You've made your point clear. Now I'd like to respond without you constantly saying 5 more seconds. Thank you. So, what type of refraction is refracting the horizon?
Well, it's usually just standard refraction, but you can obviously have looming as well. But the usual form
standard refraction, that's got an R value, and the R value would give you a tangent point. That's geometry. You understand the R in terrestrial refraction is utilising geometry of the R value that we cannot ever see and is only existing in the maths. So it exists in the maths before it's refracted something with mathematics. You see, given that geometry and this horizon is only in existence in the maths, that maths can't refract things. Your standard refraction uses maths, not atmosphere. It uses R.
Which reflects
second attempt maybe. Second attempt maybe. Need a neutral platform so that I can't say this? Yeah, you need a neutral platform so I can point out that your refraction uses R. So it's mathematical based, not atmospheric based, and R gives you a geometric horizon, a tangent point. It's geometry based. And we can't see this geometric horizon. So this is circular reasoning, a logical fallacy, where you assume your outcome, that would be Earth's a sphere, and then you use the premise that you're assuming to prove that you're on a sphere. So in this case, you're assuming a geometric horizon that we cannot ever see, and then you're saying, no, we can't see it, but it's refracted with geometry, something that we can't see. So we've got an assumption of geometry, an assumption of mathematical, claimed to be refraction, actually 7/6R. The geometry, the maths, not reality, not refraction.
Reflects reality, yes. It reflects the refraction, the bending of light. It reflects the fact there's an effective horizon that's not the same as the geometric horizon, and the effective horizon is caused by two things: the geometry of the Earth.
Sorry, the geometry would need R. So you're saying the effective radius is affected by the geometry, and we can't see that. It only exists in maths.
Well, you can see it. I say if you go up high, you can reduce it to the point where the geometric horizon, the effective horizon, are the same.
Chocolate, can you shut up? Chocolate, shut up. Sorry, Rumpus, you were interrupted.
Right, so if you go nice and high, like Al-Biruni did, and you look down, the geometric horizon and the effective horizon become very close to one, within about 5%. So if you decide to measure the radius of the Earth, you can do that using the Al-Biruni technique, and you'll get a value within 5%. But the effective horizon and the 7/6R is because the atmospheric refraction is a function of the radius of the Earth. That doesn't invalidate it, and there are obviously lots of other ways of measuring the radius of the Earth, so we know that it's correct. We know we're allowed to use R, and we know that the refraction is a function of the radius.
So Al-Biruni was measuring which horizon?
The dip angle to the horizon, yeah.
No, not the dip angle to the horizon. I asked which. You said there were several.
Oh, sorry. Okay, I missed that, but I didn't hear you. Right, yeah, Al-Biruni was measuring the dip angle to the effective horizon, but because the effective horizon from a high altitude is very similar to the geometric horizon, he then got a value within 5% of the right answer because they are close to one another when you're up nice and high and looking down.
Is the effective horizon based on the geometric horizon?
Yes.
So he was presupposing a geometric horizon, or was he trying to measure the geometric horizon? I'm a bit confused. If he's measuring something that he hasn't yet measured, he can't derive that he's got a geometric horizon based on an effective horizon, because that would be assuming it's a geometric horizon to begin with now, wouldn't it?
Yeah, he was trying to measure the geometric horizon, but...
Oh, he was trying to measure the geometric horizon, but you've made it explicitly clear that it cannot be seen and only exists in maths.
I'm trying to answer. He was trying to measure the geometric horizon.
Yes, I understood that. He's trying to measure a geometric horizon, something that you say we can't see. It's just some point that doesn't demarcate land and sea. It's not a demarcation between land and sea, so how can he possibly be measuring it? I don't really understand how something that cannot be seen and only exists in maths anyway is going to be measured by Al-Biruni. Can you explain that?
He got an answer within 5% of the right answer.
Got an answer within 5% of the assumption that he's got an effective radius based on a geometric radius he's yet to measure.
I didn't hear what you said. You were interrupting me.
Oh, my bad. I was interrupting you when I was pummeling the fact that he's measuring a point you've said we can't see, a geometric horizon. But you're saying it's within 5% of an assumption of an effective horizon based on a geometric horizon he's yet to measure.
Yeah, it's within 5% of the
of a horizon that's geometric, that can't be seen. It's in 5% of something that can't be seen.
The effective horizon is what you see. The geometric horizon is just a position, doesn't demarcate anything, but it's close enough.
So it doesn't demarcate anything. We can't see it, but Al-Biruni was trying to measure it, correct?
Yeah, he was trying to find.
Yeah, so he was trying to measure something that he couldn't see. That makes no sense.
But it was, because he knew it was close to.
He knew it was close, so he's measuring something he can't see, but he knows all about it, though, right?
Yeah.
No, he doesn't. He can't see it.
He knew that the.
Sorry, don't tell me what he knew. He's supposed to be measuring something. Why are you telling me about what he knows? He's supposed to be measuring it.
He did measure.
Sorry, he can't see it. He can't see the geometric horizon to measure it. He can't possibly be.
You can see the effective horizon.
Sorry, he just told me he's measuring the geometric horizon. The effective horizon is based on a measurement of the geometric horizon and the differential based on that presupposition. He hasn't measured it yet. He can't be comparing it to an effective horizon. He's measuring a geometric horizon, and you've said you can't see that.
No, he's measuring the effective horizon.
And what's the effective horizon? Is that based on the geometric horizon? Yes, it is, Nathan. This is the second time we've gone round in this circle now, isn't it? Why would we be going round in circles already? He's trying to measure the geometry, isn't he?
You can't think. The dip angle is independent of anything. That dip angle gives you the dip to the apparent horizon.
To the apparent horizon? But that's not the geometric horizon, so he wasn't measuring the geometry then.
He was measuring.
Sorry, he just said he was measuring the apparent horizon. That's not geometric. So you're saying he was measuring the apparent horizon. He's not measuring geometry then?
He is, because it's.
No. Apparent isn't geometric, moron.
It is, you moron.
It is. You think apparent horizons, you've just made it really clear these are different things. You stressed to me how different the apparent horizon was to the geometric and how it absolutely was not the geometric. Now you're saying he's measuring the apparent horizon. So he's not measuring geometry, Rumpus.
It's within 5%.
Within 5% of the assumption of a geometric horizon that gives you an effective horizon. He hasn't measured it yet, mate.
He's measured the dip angle.
To the geometric horizon that he can't see. You see how we're going round in circles, ladies and gentlemen? You see, Al-Biruni needs a physical geometric sphere edge to measure. And according to these fundies in the trenches, he can't see it.
Well, it's not apparent. I mean, it's not.
It's not apparent, so he can't see it then. So he's measuring the geometry of something he can't see then.
No, he's measuring the geometry of the effective horizon.
The effective horizon's based on the geometric horizon. So he's measuring something based on a presupposition of something he's yet to measure. No, Rumpus. He's measuring a geometric horizon, something you say isn't apparent. Then when I point that out, you say he's measuring the apparent horizon, something that's not geometric.
How about letting me answer? Right. So when you measure the dip angle...
To what? What are we measuring the dip angle to? Let's get some clarity. Take it a step at a time. What's the dip angle to?
Give it a try, Nathan. Let me actually answer instead of interrupting me after.
Okay, I'll ask the question. What is the dip angle measured to?
Not let me answer, will you? How about letting me answer? Give it a...
Okay, I'll let you answer. I'll ask the question, then I'll let you answer. What is the dip angle being measured to?
Sorry, I missed the... So, can you say that again, please?
You're asking me to ask you for a fifth time? Yeah, I don't mind. What's the dip angle being measured to?
The effective horizon.
Based on the geometric horizon.
Not the geometric horizon, no.
Not? So he's not measuring geometry then?
He is measuring geometry, yes.
So that would be a geometric horizon then?
No, it wouldn't, because...
So the geometric horizon isn't what you measure when you're doing geometry. You seem to not understand what geometry is.
You
don't understand what geometry is.
Answers here. I know that's what your tactic...
You're telling me he's not measuring something geometric. Well, then he's not doing geometry, and you're telling me don't understand this? Either he's measuring geometry or he isn't. He's either measuring something that's got geometry or he isn't. It's just that simple. If he's measuring an apparent horizon, as you say he is, that's not a geometric horizon.
How about letting me answer, Nathan? Right, so you asked me what he's measuring, and he's measuring the dip angle as he sees it optically, and that will give you the dip angle to the apparent horizon.
The apparent horizon's not geometry then. So he's not doing geometry. The apparent horizon isn't the geometric horizon.
Let me finish a sentence, will you, Nathan? Right.
You did finish a sentence. You said he's measuring to the apparent horizon. Well, the apparent horizon isn't a geometric horizon. So he's not measuring geometry. It's just that simple. Now, I realise that it's obviously in need of obfuscation, but you've made it clear what an apparent horizon is, and if he's measuring to that, he's not measuring geometry. Now, you don't have to like it, and communication shutdown won't work here. I've told that you many times. But if you're saying apparent horizon, and I'm absolutely certain based on your definition that apparent isn't geometric, then he's not measuring geometry then, is he?
Scaredy cat. Scaredy cat.
So is that your rebuttal? If he's measuring an apparent horizon, he's not measuring a geometric one.
Something I haven't been able to say yet, actually.
All you've done is tell me how you've not been able to talk every time I've responded by pointing out that, as you've explained, and I heard, I asked you what he was measuring, what the dip angle was measured to. You told me it was measured to the apparent horizon. Well, the apparent horizon, you've explained, is not geometric. So he's not measuring any geometry then.
Scaredy cat.
That's the same rebuttal. Every time I repeat that he's not actually doing geometry, if he's measuring an apparent horizon, you tell me that I'm a scaredy cat.
End of my answers.
Nathan, he's just saying scaredy cat to everything you're saying.
Yeah, that's because he's stuck his fingers in his ears and he's a coward. Rather than letting the rebuttal be heard, he would have to respond to it if he listened to it. So talking through it is the order of the day. So he doesn't have to respond to it. And he can justify it because, according to you guys in Discord, he's just saying scaredy cat over the top of me pointing out his problem. Now, he doesn't like that. Of course, it's the end of his argument. So the only thing in rebuttal, he hasn't got one, by the way, is to obfuscate the point. That's the only thing he can do from here on in.
So let me finish the sentence. See what it's like. See what a debate's actually like.
Okay.
Right,
Can I ask Rumpus a question?
When Al-Biruni measured the dip angle, he was measuring the apparent horizon.
That's not geometric. So if he's measuring an apparent horizon, and you've clarified that that's not a geometric location, he's not doing geometry, Rumpus. Now, I've made that point clear, and you've told me that I'm a scaredy cat.
Frightened.
You say the same thing again, ladies and gentlemen. So I've pointed out that if he's measuring an apparent horizon, as defined by Rumpus, that's not geometric. Therefore, he's definitely not doing any geometry. That's pretty much clear.
Scaredy cat. Right.
Yeah, that's an excellent rebuttal. He's not doing geometry.
How does he know he's off by 5% if he didn't have a geometric horizon to measure that to?
He's shut down, basically. He's decided that the only rebuttal he'll give to our concise demolition of the claim that Al-Biruni measured the radius by way of a dip angle measurement to a geometric location has been undone by Rumpus saying he's measuring an apparent location. Ergo, Al-Biruni was not measuring the geometric value of R. He was measuring an apparent location that is absolutely not geometric by Rumpus's own definition. So therefore, it's the end of his argument. Now, he can't let the audience know that, so it's scaredy cat as a rebuttal.
Scaredy cat. Scaredy cat.
Wow.
See? Scaredy cat. Not, oh yeah, that's right, an apparent horizon isn't geometric, therefore he's not doing geometry, because that will end the assertion that Al-Biruni established R with a dip angle measurement to the geometric horizon he can't see.
Scaredy cat.
Excellent rebuttal.
Come back, litter. Come back,
This
litter.
is better than
Rumpus.
mute.
The effective
It's just
rate
established.
of horizon,
Hold on, let's
apparent
just see if I
horizon.
can find out. I don't mind if
And
he sticks his
then
fingers in his
he
ears.
then
by this
decided
point,
to
so
use that
I'll just find
value
out
as
from Neil. Neil, did you at any stage hear my rebuttal in regards to Al-Biruni, or was it all cut off by Rumpus so that he could claim he didn't hear it?
No, all he did was kept saying scaredy cat, over and over again.
So in other words, just for the audience's benefit, so that Rumpus didn't have to respond to the demolition of his argument. That is to say that in order to measure the geometric R value by way of a dip angle measurement to a geometric horizon, you're going to need to see a geometric horizon to measure a dip angle to it. Now, he's claimed he's measuring to an apparent horizon. And the apparent horizon, we're being told by every person in the Globe Earth community, is not the geometric horizon. So he's not measuring Earth-based geometry. That's the end of Rumpus's argument. We don't have a geometric horizon, and you're going to need one if Al-Biruni's measuring to it to get an R value. This is why you haven't got R. Your globe maths is dead, fundies, and you're a butterless scaredy cat.
And let's remember, he conceded that the geometric horizon only exists in math.
Yes.
I guess we're in 5th grade now. That's what it sounds like.
See, and QE went
Here's
over this with him
here's
on
a man
Thursday,
with 4
and he still acted the same way.
horizons. He's so confused because he's got 4 horizons, and he can't figure out which one's the geometric.
Oh, he knows what's geometric. You can't see it. It only exists in maths. It's just a point in the sea that's arbitrary. It's not demarcating land and sea. It can't be measured to. Unless, of course, Alberini's going to derive an R value from that geometric location that he's presupposing. He'll need that R value to have a geometric radius actually pointing to the tangent point. That would be a geometric horizon in their reification fallacy. That would be the point that is marked with an X and labelled horizon in their model. It's the point they claim blocks boats and buildings in the distance with its physicality. That would be a physical, geometric sphere edge formerly known as Earth curve. That's what Alberuni was measuring. The geometry. And as we're being told so concisely by all of the fundies currently, we can't see the geometric horizon. We can only see the apparent horizon, which is not geometric. So Alberuni's never going to derive an R value from an apparent horizon because apparent doesn't give him geometry. The geometric horizon would give him geometry, and that's precisely what he was claimed to be measuring. Now that leaves them with a bit of a problem here at trench level because they don't have one anymore. The Black Swans debunked it. So he now needs to change the rhetoric, defy what is claimed by Alberuni, which is that he's measuring a geometric location to give him the radius value, by saying he's measuring an apparent location that's not geometric. But it is geometric, even though we can't see that, ever. It's not visible. So, if this isn't clear as crystal to the audience what's happening, you're being lied to. With doublespeak. Yeah, it's 1984. Stand alone together, people. You don't have a geometric horizon. This isn't 1984. Reality is what it is. We don't see that which you require in your mathematics to claim you've got a physical edge blocking stuff. That would be that your physical edge is physical and based on geometry. It's not. Your fundies even admit it, and it leaves you with a very real problem when the very maths that you're going to use to claim refraction's moving it needs an R value to have at some point, i.e. Alberuni, have had a measurement to it. And if you can't see it, you can't measure it, you don't have an R value. Let's do a quick few shout-outs to Unitox Femu, who says, Rumpus, please stop. I moved my kid in the other room. Thank you very much indeed for the super chat. A Cruel Vision ACV says, I became a flat earther by listening to Rumpus. Seeing that level of stupidity is a flat earth proof in itself. He is my second favourite flat earth proof. Very amusing. I love it. Okay, there was one other. Let's see if I can scroll up. It's too big to fit on my screen. Here we go. It's Flat Earth Data. Thank you very much indeed for the super chat, Flat Earth Data. What causes Alberuni's horizon? Earth curvature or eyesight? Rumpus. Make an angular resolution orthographic drawing. Thank you very much indeed for the super chat. And with that, I'm going to say first and foremost a huge, massive, enormous thank you to both Discord and G+ panels for making today's live show possible. If you are watching on either the Nathan Oakley 1980 or Nathan Oakley premiering streams, then stay tuned as there will be an after show to follow. Be sure to check out NathanOakley1980.com and the Flat Earth Debate Forum to keep up to date with the community debate. Another massive thank you to all of you who smashed the super chat, liked, commented, shared, subscribed, and all that good stuff. Once again, stay tuned if you're watching on a premiering stream. I've been Nathan Oakley, and I'll see you all in the next video.
What a day! What a lovely day!